Number 3 gives us the shape log base 2, and these two endpoints for our y and our x, as shown in the figure below. It says that we're going to do cross sections that are perpendicular to the x-axis, so that means we're going to be leaving things in terms of x, and we're going to be using cross sections that are squares. So then we're going to need really just to know what the length of one side is, and then we'll square it. So when we're setting up this integral, we are using x values, the first of which is given to us. Like, we know that this shaded area begins at an x value of 3, but we don't really know where it ends. And when I look at the options, I see actually all of them starting at 3, but not knowing where it ends. And so that's something we're going to have to find ourselves. We need to find this point of intersection. So we're looking for when these two functions are equal to one another, log base 2 of x. You have solved these types of equations in pre-calculus. This would be like the chubby hand rule. 2 to the what is x, so 2 to the third is 8. So then that means these two functions intersect at an x value of 8. So our integral is going to be going from 3 to 8. Because we're doing cross sections that are perpendicular to the x-axis, that means we're going to have a dx for our variable of integration, as we see here. We are doing our upper function, which is 3, minus our lower function, which is log base 2 of x. And that represents sort of the like width of each of our rectangles. Their height is just going to be the same thing because they were squares. So then we're just squaring that into grand, which looks like option D. I'm sure most of you probably would have stopped when you had the 8. That was probably all you needed there.